This is the arrays lecture for CIT 130. In this presentation, I want to talk to you a little bit about what is covered essentially in Chapter 8 of the Gaddis textbook, which is the concept of arrays and array lists. There are some topics in here we aren't going to um, cover all that hard. We're going to hit mostly the basics. While some of you have had the basics in other courses, it is entirely possible that many of you have not even really talked about the basics of arrays. We are going to move kind of fast. I do expect that you have some knowledge of Java at this point, and so you're going to be able to understand some of the topics and some of the processes that we're going to talk about for using an array. This is going to require that you do remember how loops work, because we are going to be seeing loops come again in this discussion and the activities that do follow. So we're going to talk about an introduction to arrays, talk about what they are, how they work, how to use them, how to process their contents. We're going to talk about using arrays as arguments to methods. We're going to talk about some useful algorithms and operations. We're going to talk about returning arrays from methods, so how to pass arrays as values, how to get arrays back. We're going to talk about arrays of string objects. We're going to talk about arrays of other objects. We're going to talk about the sequential search algorithm, which is really useful when you're dealing with arrays. We're going to talk about command line arguments, and if we get an opportunity, we will even discuss for a few minutes the array list class. So, as an introduction, to start things off, let's talk about the basics of arrays. First of all, we have sort of a problem here. Everything that we've done up to this point has used primitive values, integers, numbers, to create variables, and those variables can only hold one value. What happens when we need to hold more than one value? Arrays allow us to create collections or lists of values that are indexed so that we can access every position in that collection or every position in that list. We of course again, I liken an array to a list of data, like a grocery list, but there are some restrictions, and one of those restrictions are that all of the data that we're going to store in that collection has to be the same type. So I can have a collection of integers, I can have a collection of characters, I can have a collection of doubles, I can have a collection of strings, but I can't have a collection where one thing's an integer, another thing's a double, something else is a float, and maybe something's a character. That doesn't work. They've all got to be the same type. So they're our lists are typed. We use our data types to tell Java what kind of data we want to store in our lists. And finally, of course, they're data elements, right? These are values that we want to store together. When we create an array, we have to keep in mind that arrays are objects. Even though we could be dealing with primitive data, these are collections of primitive data rather than an individual primitive data variable. So things are going to be a little bit different here. First of all, what we have is that, like with a lot of things, we have got to create a reference variable. This is going to be a variable that is going to hold the reference or hold the memory address for where this collection is going to be located. Now, there are two parts to this. The first part is going to be the data type followed by a set of square brackets. And the data type followed by a set of square brackets tells us, first of all, that it is a list of, and in this case, ints, so integer numbers between negative 2 billion and positive 2 billion and some change. The name of the list is then numbers. Once we have a reference to a variable, once we have a variable that's going to hold the array, we can go ahead and create it. And again, with the creation, notice the new operator. Because we're dealing with an object, we have that new operator. Now what comes after it is a little different than anything we've seen before. Usually with the new operator we see a constructor. It doesn't quite work that way with an array, because an array is a collection. Again, we see the data type, and then we see those square brackets again, but this time it's got a number inside. What that number is telling us is how many items is going to be in that list of ints called number. And of course, they're all going to be of the int type. So what that does is create an array, a collection, a list of ints called number. Now, one way we can visualize that array is in the way we've got here at the bottom of our here at the bottom of the slide. And I apologize that my mouse work in blocking that off is not very good. But this is like the best way I've come up with to visualize an array. Each block here is an element or an item in that list or collection, whatever you want to call it. Each one of these is an element or an index or an item in that list. And each one of those items has what we call an index or a subscript, and it starts at 0. All arrays or lists start at 0. And so we have 0, 1, 2, 3, 4, 5 items. So that gives us 6 actually, because we count 0. 0 stands for something. So that's our list. And that's sort of how it's stored in memory as well. When we are creating an array, we can do the whole thing on the same line. There is no problem, doing it all on one line like we have any other object. Again, you're going to see the int and the square bracket, again, telling Java it's a list of ints. You're going to see the name, so that's the name of the list, numbers. The new operator, along with int again, just reminding Java that it is a list of ints, and that there are 6 of them. That there's going to be 6 items in that list. And again, this is a good example of doing everything all on one line. Of course, the arrays can be of any type. What we see below, the code that we see below, that starts out with float square brackets, temperature is a list of temperatures that are going to be in a decimal that ends after 6 or 7 places after the decimal point. The second one we see on the bottom is letters, right? It's a list of, or a collection of characters called letters, and there's going to be 41 characters in that list. Longs, right? These are integer numbers that are above 2 billion. Units, we've got a collection called units that's going to store multiple longs, and it's going to store 50 of those. I just want you to realize that arrays aren't limited to integers, they can be anything. When we're specifying a size for the array, we're not stuck to just a literal number like 6. We can use a variable or any other anything that results in a non-negative integer number. It can be a variable, some sort of equation, input from the user. It doesn't matter, just so long as it is a non-negative integer number. So as long as it's an int that is not negative, you're not going to have a problem. In the case of the example here, we're creating a constant called array size. We're setting it to the value of 6, and we're substituting the constant variable name array size instead of the number 6, and that's fine. The thing that you need to know about creating arrays, though, is once you have decided how big you want, how many items you want to store, you need to keep in mind that you're not going to be able to change that. Array sizes are fixed and can't be changed once they're declared. when we have this array, how in the world do we get access at the individual items stored in it? It's pretty simple. We use the name of the list or the name of the collection, in this case numbers. Then we use the square brackets again, but this time we specify a location in that list. Now remember, the list locations always start at 0. And as we're going to find out in the next couple of slides, the last possible location is going to be whatever the size of the list is minus 1. So in the case of a list of 6 items, we can first access, our first location to access is going to be numbers, and the subscript or the position is going to be 0. So that gives us the location in the list, and then we can treat that like any sort of variable that we want. As you can see, we're treating it just like any other integer and assigning the value 20 to it. Again, array elements can be treated like any other variable. They're simply accessed by the same name and then a subscript. And array subscripts can be accessed using variables as well. You don't have to put in a number. This subscript that we're seeing right here, and let me highlight it for you. This subscript that we're seeing right here, or that we see, up here toward at the top in our little diagram, when you specify these in your code, they don't have to be literal numbers. You could use a variable. Again, it's got to be non-negative. So start at 0, and it's allowed to run till the end of the list. Again, bounds checking. Bounds checking is this idea that we have a starting point and a stopping point, and we don't want to go around those. I sometimes like to think of arrays as a floating platform, and if we go off either end, we're going off the cliff. So you want to make sure that you don't you don't go too far off the end in the higher numbers, and you want to make sure you're not trying to access anything less than 0. The -1 doesn't really exist. It's not a position in a list. So keep in mind that they always start at 0, and they continue until the size of the array minus 1. When we think about an array of integer values called values, and we say that we're going to make that integer hold 10 items, or that array hold 10 items, or have a collection of 10 items, our indexes are going to be 0 through 9. And like I said before, we don't have to use literal numbers to access those items. We can use variables as long as they're non-negative and within what we call the bounds of they're non-negative integers, and they live within the bounds of the array. So again, going back to that visualization of the numbers array we saw earlier as sort of blocks or cells, right? 0 is where we start. In this example, values, 9 is where we end. If we go off of 9, we don't exist anymore. We've jumped off the cliff. If we try to go below 0, again, there's nothing there. We've jumped off the cliff. So we want to try to make sure that we're staying within those areas. And it's fairly easy to do. And we can even use a for loop to help us with a variable to act as our index. But when you're doing this, it's very easy to be off by 1. Very easy to be off by 1. In the case of this for loop that we see here, the equal sign causes us a problem because it's going to allow us to get to 100 and try to run the loop. The problem is if we have a loop, if we have a list of 100 items, our indexes start at 0, so 0 is always good, which our for loop starts at 1, and that's fine. It could start at 0, and that would be fine too. But it can only go to 99. And I know this because all lists all the indexes for all lists go from 0 to whatever the size of the list is, minus 1. Now, if we do happen to run our code in such a way that we run off the cliff, that we do go ahead and try to swan dive off the cliff, whether by user error, they inputted something wrong, or by some code changes that we made accidentally, maybe we did our for loop incorrectly like we see here in the example, we're going to get an exception. The code's going to throw an exception. We talked about exceptions last week, or the last time we met. And so the exception is going to be an array index out of bounds exception. Now remember, your bounds are the valid areas of your array. That's going to be 0 to size minus 1. In the case of a 100 item collection, it's going to be 0 to 100 minus 1, which is 99. So everything from 0 to 99 is perfectly accessible, and we haven't gone anywhere. But the minute we go past 99, we've jumped off the cliff. There's no more spaces. There is no more to the list. So we've jumped off the edge. And when we jump off the edge in our code, when our code is running, our code is just going to stop running, and we're going to see an array index out of bounds exception. This might be one of those exceptions that you might want to write a try-catch block around, just to deal with when you're working with arrays, in case the user does make a stupid mistake, or you do run over the edge. Creating arrays like we saw in the beginning, where we specify a size and tell it how many items we're going to have, isn't the only way to create an array. We can also create an array by providing it the initial values for each spot in the array, for each position or location. So in the case that we have here, we have an item, we have a list of 12 integers called days, and they represent the amount of days in the months of the year. So for January, there's 31 days. For February, there's 28. For March, there's 31. April, there's 30. May, 31. June, 30. July, 31. August, 31. September, 30. October, 31. November, 30. December, 31. And I just, that's how I provide it. You use the data type that you wish to store in the collection or list. You use a set of square brackets to indicate to Java that this is not just going to be a single value of that data type, but a collection of values, or a list of values at that data type. The name of the list, or collection, or array, whatever you want to call it. Then in curly brackets, the data that you want to put into each of those spots. It could be a list of strings. It could be a list of, like in this case, integers. It's all up to you. When this happens, the values are stored in the order that they are listed in the list. So 31 goes to index 0, 28 goes to index 1, 31 goes to index 2, and so on and so forth. Essentially, it's a mechanism to make our lives easier. You might see arrays declared in slightly different fashions, and this slide provides you with some of those exceptions. You might see the square brackets show up in slightly different places. The first style is the style that we normally use, but the second style is something that you might see. I think it was done to be a little more compatible with other languages. Not every language puts the square brackets in the same place. You might declare multiple array variables on the same line. These are variables that are going to store the reference to your list. And then there's even an alternate notation that creates a list of numbers, a list of codes, and then a single variable called scores. So you do have to be careful how you set these up, but you can set up individual items and lists of items all in the same declaration, just as long as the data type is the same. When you want to use the value stored in a position in the array, it's really simple. As simple as it was to access that and assign it a value, we can use that value in the exact same fashion. It is simply the name of the array. In the case of the example you see here, gross pay equals hours sub 3 times pay rate. Hours is the name of the list, collection, or array, and the square brackets tell us we're looking for a specific subscript, and then the subscript number that we're looking for, 3. So we're looking for the 4th item in the list. Pre and post increment work the same way. If you don't understand what that is, that's okay. Array elements can be used in relational operations as long as they're numeric array elements. So I can compare the cost, the value stored in cost 20 with the value stored in cost sub 10. That's not a problem. I can use them to decide as I can use variables or array items to count loops if I so choose. It's not that hard because, again, it is just a value stored at a specific position in a specific list. Sometimes we're not going to know the length of our arrays. Sometimes we're going to get an array from somebody else. Sometimes a user is going to provide you with some sort of indication on how big this array should be. If you ever find yourself in a situation where you need to find out the size of an array for any reason, just a quick count of how many items that you have to ensure that you have some stuff. Let's say you're reading from a file or a database, to just, somebody else produced this array. You're using their code to make that happen. You just need to know how many items are in it so you know when to stop processing it. There is a way, Java's provided a way for us to find that information out, and that is called the length constant. Every array has a constant data item called length that you can use to determine how big or how many items an array has. In the case of this example, we're creating a collection or an array of double values that's called temperatures. So I think I can gather from this that we're going to be storing 25 temperatures in this list. We know the length of the array is 25, but let's assume we don't. How can we find out? Every array has a length property. Notice I said property and not method. Notice in the code example at the bottom of the slide that there are no parentheses. This is not a method call. This is a property. This is a data item. Somebody made this public data item when they designed the array for us. Let's take advantage of it. I'm not a big fan of that. I wouldn't suggest you do it either, but sometimes it's necessary. So what we can do here, like I said, is ask temperature.length, and it will tell us how many items are in the list so that we don't have to know. The enhanced for loop is probably one of my favorite things on the planet. Let's say you have a list. Let's say all you want to do is look through each individual value of each item on the list. The enhanced for loop is great for that. It is a much more simplified format. Basically, the way it goes is for, and then a data type and a variable name. And that variable, every time we run the loop, that variable is going to hold the next item in the list, a semicolon, and the name of the array. That's all it is. And it's going to look at and give us the ability to access each item in the array. Now, the thing that I love about this is it's so simple, but it is read only. We can only see the data. We can't change the data. So that is a bit of a downfall. The other thing is that I'm never going to mandate to you that you use a particular type of loop. In this case, what I'm going to tell you is this loop is available and you can use it if you want. If you don't want to, that's okay too. And you can use a regular for loop, whatever you're comfortable with. We are going to see this in some example code that we do, and the follow-up discussion that comes with it. I'm going to show this to you. Here's an example of the enhanced for loop. But I call this the for each loop. Microsoft uses this in their products, in their .NET framework, and they call it a for each loop, for each in loop. I kind of like that. And so I kind of, when I'm reading the code, I read it that way and it makes more sense to me. We've created an array of numbers containing 3 items, 3, 6, and 9. So index 0 is 3, index 1 is 6, index 2 is 9. So we're saying essentially for each integer called value in a list called numbers, we're going to print the statement the next value is and the value of the variable val, which stores whatever the next number is in the list. It's really pretty simple. I think it can be sort of hard in its simplicity, but I love it. I absolutely love it. When we think about array size and we're doing loops, the length constant, the array name.length, can be used for bounds checking. We can use it to make sure that we're not running off the end of the array. But basically, things we got to keep in mind. The subscripts start at 0. So our loop control variable, I, in this example, needs to start at 0. When we're doing our test, we need to make sure we end at 1 less than the length of the array. So we need to make sure that we use the less than rather than less than or equal to. There is this knee-jerk reaction that if I got 100 items in the list, my indexes end at 100, and they don't. They end at 99. The one way to make sure that we don't ever get to 100 is not to allow the test to succeed. To make that happen, we have to make sure that we stay under 100 so that the highest we ever get is 99. It is possible for you to let the user decide how big your array is going to be, especially if they're going to be entering the data into it. You want to make sure they're aware of the size, that you've communicated to them somehow how big that list is going to be, and or communicated to them that they can set the size of the list. And this is some example code on how to do that. Essentially what you're doing is you're setting up the number of tests that have been turned in. You're setting up an array or a list of those tests. I assume they're scores by the fact that we're using an integer. We're asking how many tests you have. We're asking the question how many tests you have, and then we're giving them the ability to respond. Once they've responded to that question, we're going to convert that. In this case, we're going to use that. So we're going to make sure that it's an integer, of course, and then we're going to use that value to plug into the creation statement for our arrays. In this case, we've already got the variable called tests. Now we need to set up the list with a number of items, and we can do that. In this fashion. Again, this code's pretty solid as far as a good explanation of how to allow the user to specify the size of an array. We can assign array references to other variables so long as it is defined as a list of the same type of items. Again, the idea here is that the variable stores an address, which has the actual array, and if we reassign it a new list, the old list gets marked to go away. The link gets cut, and we end up with a new list, in this case with 5 items. Sometimes we might need to copy arrays. The way you see here is in the code example, and then the sort of the diagram that goes along with it is not correct. We do not want to copy an array by assigning the value to the list, because we're now giving somebody else access to that list, and that's not, or that array or that object, and that's not necessarily what we want to do. So this is bad, 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 bad. There is a better way to do it. Basically, when you're copying an array, you want to end up with two discrete, I don't want to say different, but discrete individual arrays. You don't want two variables pointing at the same block of memory. You want two separate blocks of memory. And when you do that, here's some things you need to think about. You're going to have to do the work the hard way. You can't just copy it. What you need to do, what would an identical array look like? Well, it would be the same size, and it would contain the exact same values. Well, we've already seen how to loop through and access the values of each individual element of an array on a fairly quick basis. That works wonderful. And we can do that. So first we got to create the array at the correct size, and then we can go through and start putting in the items. It's a lot more work than just assigning variable names new values, but it will result in the duplicate copy that we need so badly. We can also pass array elements to methods just like they were an individual item. Okay, if you have a method that requires, let's say we have a list of integers, and you have a method that requires an integer, it is very simple to just pass the value by saying array name, square brackets, and then whatever position in the array the value that you're looking for is located at. More often than not, though, you're going to want to write methods to process the array data by passing the entire array, not just one element at a time. But there are methods out there that have lists of stuff, or that require just one item in order to do its work. And you can very easily do that just by accessing an individual item of the array and passing that item. However, if we do want to pass the entire array, that does introduce some things that we need to be aware of. If we decide that we're going to pass the entire array, we have to remember that arrays are objects, and that they are passed by reference, which means that the address of the original array location is what is transferred, not a copy. Most of the values that we've dealt with in both 111 and in 130 have been passed by value, which means a copy is made. When we're dealing with objects, especially arrays, we end up passing by reference, which means that we're essentially handing around the original copy of the array. So you've got an example here of a call to a show array method, and you're passing in an array called numbers. And then at the bottom of the screen here, you're seeing this method basically. And the only difference is when we're passing an entire array as an argument, the only thing that we really need to do is right here by the data type, you see the square brackets, and that just lets Java know that they are going to be, that it should expect a list rather than an individual item. When we're comparing arrays, we've got some things that we need to think about. We can't use the double equals. It doesn't work. Basically, all it's going to do is tell us if the two reference variables are pointing to the same memory location. Ideally, they wouldn't be. If we've got two reference variables, they should point to two distinct arrays. So how do we check and see if two arrays are the same? Well, we have to think about what makes two arrays the same. Basically, we're going to have to check and make sure that they are the same size, and this code does that right here. Okay, so right here where you see my mouse spinning around, that is where we are checking to make sure that the arrays are the same size, because if they're not the same size, then they're not going to be the same. And then the next thing that we need to do is we need to, if they are the same size, then we need to go through and make sure that each element, the data in each element is identical. So basically, for two arrays to be identical, they have to not only be the same size, but have the same data in the same locations. That would be two identical arrays. And again, this code will do that for you. Let's take a look at some useful array operations. Sometimes we have a list and we might want to find the largest number in a list of numbers. And we've got some code to do that. Basically, I'm going to walk you through what this code does. First, it says, assume we have a list of 50 numbers. We're always going to assume that the first number is the highest number. I realize that it may not be, but we've got to start somewhere. So we take the first item in the list and we make it. We create a variable called highest, and we set it to the first value in the list. Then we look through the rest of the list, and we ask the question: is the current number greater than the highest number we found so far? If that's true, that means the current value becomes the highest value, and we just keep on checking. By the time we're through the entire list, we will have the largest number. When you're doing lowest, you do the same thing. You always assume that the first item is the lowest value in the list. It may not be, and that's okay. But you always assume that the first item is the lowest item, and then you check through the entire list and you ask the question: is the current item smaller than the lowest item? If it is, then the current item becomes the lowest item, and then we just keep repeating the process until we get to the end of the list, and by the time we're at the end, we'll have the smallest item. If you don't think that works, follow this process on paper. Create a list of numbers. Follow this process on paper and see what you end up with. I guarantee you it will work. Sometimes we find it useful to add all of the values in an array together. And there's code right here under summing array elements. And that's the word we use when we add a list of numbers together. It's called summing them. We can use this very same process that you see under summing to add together all of the items in a particular list. So we're going to take our list called units, and we're going to set a total variable. And then for each item in the list, we're going to add that value. We're just going to keep adding that value to total as we go through for each item until we hit the end of the list. If we want an average, we can simply divide that total by the number of items in the list, and that'll give us the average. Sometimes we may find ourselves in the particular situation of what we call a partially filled array. Let's assume we don't know how much data we might have. We may know that we can have no more. For example, I never know how many students are going to be in this class. I know that I can have no more than 22 students in this class, but I never know if I'm actually going to get a full course or not. As you look around the seats when you're in class, you can tell we don't have 22 students in class. But I always have to assume that we have I could have at most 22 students. So how do I deal with that? How do I deal with the fact that I may not um, that I may know what the upper end of how many items I may what's the largest number of items I may have in my list, but I never know at any given point how many of those spaces might be filled. What you can do is use something called a partially filled array. And to do this, basically, not only do you need to know how many spaces does the array have, or the length of the array, but you also need to keep track of how many spaces you've used. So you're going to have to keep an extra counter for the number of spaces you used. It does get a little more complicated because you do have to keep track of what the last available space was. But it can be done. And this code gives you an example of how to do it. And I just want you to know that input number and keyboard were previously declared in this example, and keyboard represents a scanner object. So basically what this is this is getting the user to provide a number, an integer number, and until they select -1. And so we don't care how many numbers they may enter. We're capping them at 99, but that's it. That's the only thing we're doing. As long as they enter 99 or less numbers, we're okay. The one thing I dislike about this lecture is it does seem like it's sort of all over the place. So we jump from partially filled arrays to returning arrays as references. Arrays can be returned just like they can be parameters. Of course, we can use them as return types. The big thing that we have to do here is make sure that when we specify the type of return data, we're putting in the double quote, or the not the double quotes, but the close blocks, the square brackets, the opening and closing square brackets, so that we can let Java know that this isn't just a single double value, but we're actually going to be returning a list of double values. And then, of course, you have to make sure that you're dealing with a list or an array inside your code, and that you return that data. Arrays aren't limited to primitive data. We can have arrays of objects. So basically, anything that that is a class can have, we can make a list of it. So strings, we can have a list of strings, and we've talked about this. You've seen this sort of list of strings before when we were talking about all of the different components that we had for our graphical user interfaces. When we talked about the list components, the checkbox, or I'm sorry, the drop-down box, or combo box, not checkbox, combo box, and the list, we talked about these arrays or lists of strings. Basically, what we've got is a variable that holds the address, the reference variable that points to the memory where the list is being stored, and then a list of string objects. The thing that we need to keep in mind when we do this is that when we initially create the list, that the list is null. In other words, there is no values in each of the positions on the list. And not only do we have to create the list, but we have to initialize each element with the new operator. Strings not so much, but we do have to do that when we are doing objects, which we'll see in just a few slides. One of the things that we need to think about is, of course, we can call string objects, all have several methods, up to uppercase, compare to, equals, character at. We're going to talk about all of these in another lecture. But we can do it on each element of the array since each element is a string object. We have to keep in mind when we're dealing with strings that arrays have a field named length and strings have a method named length. And so if you want the length of a string in a spot on the array, what you would do is similar to the system.out code that you see here. Keep in mind that the array's length field is a data field. It is a data member. So you're not going to have parentheses, whereas the string's length property, if you will, is actually a method. It's not a property, it's a method. The way to access the string's length is a method. So you're going to call the method with the with your parentheses. Strings aren't the only types of objects we can have. We can have any object, including programmer-created objects. In this example, we're using a list of bank accounts that holds 5 different bank accounts. And again, when we're putting values into that list, because they're objects, we are going to need to use the new operator. You can see here for each account. So account sub 0 equals new bank account. That will call the bank accounts constructor. We're going to have to do that for every item in the list. And you know what? This is one of the things that makes arrays so powerful. The ability to move through it with the loop is one, but the other one is the fact that we can create lists of other objects. Really makes this powerful. The big thing here is to remember that just like any reference variable that you create for an object, you have to declare when you go to create the object and use that new operator. You still have to do that when you're doing a list of those objects. In this case, you're going to do it for each element of the list. Something I think should have been thrown in the useful algorithms for the useful array processes section is this idea of the sequential search. I really don't understand why they wait and sort of stick it towards the end. The idea behind a sequential search is the idea of looking through the list for a particular item. So basically, we look at, and they call it sequential because we start at the beginning of the list, and we go through until the end of the list, and we look at the value of every item to see if we can find it. Basically, we're going to use a loop, and we're going to step through each element in the array or in the list, and we're going to compare each element to the value that we're searching for, and we're going to stop when either A, we've hit the end, or B, the value is found. And we're going to look at a couple of example programs that do exactly that. How many of you have looked at your main method from 1.11 until now and said public static void main string array of arguments? And you look at that, and after we talked about building methods, you said, okay, that's great. My main method takes a string block of arguments. That's a string array of arguments, so that means that's an array coming in. So that's great. Where does that come from in this main method here? And how do I take advantage of that? Well, that's something called a command line argument. If you've ever used Microsoft DOS and you've ever typed in the directory /p command, and for those of you who remember the good old days, the directory /p command paginated the directory so that only it would only display what the screen was capable of displaying and prompt you to hit enter to see the next set. It basically created pages of your directory listings. It was great. That was called a command line parameter. That /p was called a command line parameter. Java provides us with the ability to use command line parameters when we call our programs so that we can intercept those command line parameters and do something with them. Those command line parameters head into the args variable. Of course, you could call it whatever you want, but in this example, it's the args variable, and it comes in as a as an array of strings. Basically, every time there is a space, it breaks it up into smaller and smaller strings. If we look at an example, when you run a Java program at the command line, now in most cases this is all done for us in this class through our use of the development environment. But if you were doing it the old way and you were using the DOS prompt, if you would type in the command Java, followed by a space in the name of the program you wanted to run. Then after that, you could put a space, and everything that followed that space would be part of a set of command line parameters or command line arguments that could be passed into your program. So what happens is this gets passed, in this case the phrase, how does this work, gets passed into the program command line's main method. And again, there's that string array of arguments, so Java breaks this up into an array of arguments, and we've called it, in the example we just saw on the previous screen, args, so we're going to stick with that. And in this case, args sub 0 is how, because that's the first command line argument, so that goes at the top of the list. Args sub 1, I realize the subscripts in the slide are incorrect. You can thank your book publisher for that one. Args sub 1 gets does, as that's the second word, or the second command line argument. Args2 gets this, as it is the third command line argument, and args3 gets work ? As it is the fourth. And the array is broken up on the spaces between, in this case, the words of the sentence. So every time there's a space, then that'll break to the next argument, or to the next item in the array. Again, the main method's parameter doesn't have to be called args. It's just kind of what everybody does, and NetBeans does that too, and that's perfectly fine if that's what you want to use. We're going to jump ahead a little bit. I'm going to skip the generics here and see. I think we're just about done there. So that's all I've got for you on arrays. We're going to skip the array class discussion because that's not really part of the lecture. And if you have any other questions, of course, please feel free to let me know. You can email me, bsimbeck@ccac.edu, or you can contact me, or you can ask me your questions in class, and I'll be more than happy to help you. Thank you for watching this lecture. Following this lecture are a number of exercises for you to try, followed by video walkthroughs of those exercises for you to watch to help you through them. Again, if you have any questions about any of this, please let me know. Thank you.